Welcome to Rizzi. Now we are continuing the session that is parabola chapter here. In that parabola, this is a normal of a parabola here we are going to discuss here, and this is the last class for parabola chapter introduction. After this class, we will go for problem solving of JEE mains here, and we have several points for normal of a parabola here. This is the topic name is normal. Normal, generally what is normal? For example, if you take any parabola here, this is a parabola, and for this parabola I am taking a tangent, this is a tangent. For this tangent, a line is perpendicular to this tangent at point of contact. This is point of contact, this is point of contact, and here a line is perpendicular to the tangent. This is tangent T and this is normal here. The perpendicular, a line is perpendicular to the tangent at point of contact, and a parabola is called normal of a parabola. This is the information about normal. Here normal is nothing but a line which is perpendicular to tangent at point of contact on a curve. It may be parabola or circle or straight line, and ellipse, hyperbola, we have several types here. So for any curve, or if you take any straight line as also normal, you can write for any tangents here. The line which is perpendicular to the normal tangent at point of contact is called normal here. And if you look at the first point, equation of a normal to a parabola, y square is equal to 4ax. Y square is equal to 4ax is nothing but it is having vertex 0, 0, and at point x1, y1 is directly you can substitute. If you know the point of contact of a parabola at tangent, and for that tangent we can draw a normal, and if you want to find that normal equation, you can substitute x and y1 values in this expression. You will get the equation of normal. What is the equation of normal here? Y minus y1 is equal to minus y1 by 2a into x minus x1. This is a remembering formula for to find the equation of a normal when a point of contact for standard form of a parabola equation is given. This is the most important one. And the next one, equation of the normal to the parabola, y square is equal to 4ax, which is having vertex 0, 0, and having slope of that tangent, slope of the particular tangent. For example, this is a parabola, this is a normal, this is a tangent, and this is a normal. For example, if you know the slope of this normal, we can find the equation of a normal here. What is the expression here? Y is equal to mx minus 2am minus am cube here, where m is slope of a normal here, and a is a distance between vertex to focus here. This is called a here. If you substitute a and m values in the expression of y is equal to mx minus 2am minus am cube, then we will get the equation of normal when slope and parabola equation is given. This is for slope, this is for point and parabola is given for normal equation. This is slope and parabola is given. This is the expression for to find the equation of a normal here. This is all about the second part. And the next point is the condition for straight line, that is equal to y is equal to mx plus c. It is a straight line equation which is having slope and intercept form is normal to. This is a normal. This straight line is a normal to a parabola, that is y square is equal to 4ax, where y square is equal to 4ax is a standard form of parabola that is having vertex 0, 0, and then c is equal to, then the intercept. What is intercept here? Intercept c is equal to minus 2am minus am cube, minus 2am minus am cube. Here if you observe this equation and this equation here, if you compare, y is equal to mx plus c. In place of c, this is the value is set. So then the intercept will be minus 2am minus am cube, where a is the distance between vertex to focus and m is the slope of a line. Slope of a line. Which line here? Slope of a normal here, not tangent and not any axis here. Here slope of a normal here. So and foot of the normal, foot of that normal point. If you want to know the foot of the normal point, for that, if you substitute the values in this point formula, you can find the foot of the normal. That is am square comma minus 2am here. You can substitute a and m values from the given parabola and normal of a line here. This is all about the third point. And the next point here, the condition for the line. Here condition for the line, Lx plus my plus n is equal 0. This is a straight line equation. Lx plus my plus n is equal 0 to be a normal to this parabola. To normal to this parabola, that is standard form of parabola, y square is equal to 4ax, and this is the parabola, and a tangent here normal is given. This normal line is Lx plus my plus n is equal 0, and then the condition, this is the condition for a straight line is in the form of Lx plus my plus n is equal 0 to a straight line, that is Lx plus my plus n is equal 0. It is normal to the parabola y square is equal to 4ax. Then the condition is al cube plus 2al m square plus m square n. These are all remembering conditions and formulas for normal here. If you are perfect in these formulas, you can crack all the JEE problems related to normal very quickly here. And the next point here, the equation of normal. The equation of normal, remember it, that is the equation of normal to a parabola. This is the parabola here. This is x square is equal to 4ay. How it looks like here? X square is equal to 4ay. This is the parabola equation, which is parabola from here, and which is passing through origin and having vertex 0, 0, and slope of normal. He is given one slope. This is the tangent here. This is the normal at point of contact here. If he is given slope of this normal and the parabola equation x square is equal to 4ay, then the condition for x is equal to m by minus 2am minus am cube here. Just if you observe the second point and this point here, just in place of x and y, just they are replaced here. X and y's are replaced here. That's why here we are getting this equation. Here if you observe, this is a standard form of parabola. Here this is in second quadrant and third quadrant parabola here. This is a first and second quadrant parabola here. So x square is equal to 4ay. This is positive side here, and if slope and formula of parabola is given, this is the condition. Here standard form of parabola and slope is given. Just in place of x and y replaced here, we'll get the condition for normal. Easy to remember this formula here. And the next one is here, all the points are completed, 5 points are completed. Next, here equation of normal to a parabola y square is equal to 4ax. This is a parabola normal, y square is equal to 4ax at point t. That is the condition, equation of normal. At point a parabola that is having vertex 0, 0, and which is having a normal at point t. And if you want to find the equation of a normal at point t, that is the condition y plus xt is equal to 2at plus at cube, where t is in parametric form of a parabola. Here you have to remember this expression to find the equation of a normal when t is given here. And the next point is slope of a normal at t on y square is equal to 4ax is minus t. Here slope of a tangent at t y square is equal to 4ax is y square is equal to 4ax is minus t. Here for tangent slope is t here, and normal automatically it will become minus t. In last case we discussed about slope of a tangent at point t is t only. Here perpendicular, here tangent and normal, this is normal, this is tangent. Always tangent normal are perpendicular to each other, perpendicular to each other. So this is all about this point here. And here the next point is, if two normals are there, for example if two normals, I am erasing this point here, if two normals, this is a parabola and this is one tangent normal, and this is also one tangent, and this is also one normal here. This is n1 and n2, t1, this is t2 and this is t1. Two tangents, two normals. This is a parabola here. And if two normals at t1 and t2, this is t1 and this is t2 on a parabola, and y square is equal to 4ax are perpendicular, then the condition is t1 into t2 is equal to minus 1. Simply when comes to straight line is also the same thing is happen here. Perpendicular, when two lines are perpendicular, then the slopes are their slopes is equal to t1 into m1 into m2 is equal to minus 1. Here also the same thing will applies here, and t1 into t2 gives minus 1 here. This is the condition for when two normals are to a parabola, y square is equal to 4ax, that is the standard form of parabola. Then the condition for between these two points is t1 t2 is equal to minus 1. This is the important one here. And the next one, the tangent. If you look at the final point in this one, the tangent at one end of the focal chord, remember it, this is the only informative point here. The tangent at one end of the focal chord of a parabola is parallel to normal at other end. Remember this point here. So here first we have to understand what he is saying. In diagrammatically we can conclude easily here. So I am taking axis here, this is axis here, this is a parabola, this is a parabola I am taking here. So this is a parabola, and I am taking a focal chord, I am taking a focal chord, this is a focus, this will be the focus S, and I am taking a focal chord, this is a focal chord, this is a chord. At one end, this is one end, this is one more end, two ends are there. One end, this is one and two here, two ends are there. At one end he is saying one end of the tangent, this is the tangent, this is a tangent. Focal chord is nothing but which is passing through, this is a tangent here. So and if you other end if you draw a normal, this is a tangent and this is a normal, this is a tangent. So I will show you clearly. This is a parabola and this is a focal chord, and if you draw a tangent here, if you draw a tangent at one end of the focal chord, this is the one end of the focal chord here, this is the tangent T1, and other end, if you draw a tangent, this is a tangent here, this is T1 and this is T2 here. For this tangent other end, if you draw a normal, this is the normal here, and if you draw like this, if you draw like this, this is also, this is the normal here. So this is normal. So understand the point here. The tangent at one end of the focal chord. This is focal chord. Focal chord. This is focal chord. It is at one end. If we draw a tangent, that is T1. T1 is the tangent at one end of the focal chord, that is T1 here, and the other end of the parabola, and the other end of the parabola here. This is the other end of the parabola focal chord. For this point, if you draw a tangent, if you draw a perpendicular line, that is nothing but normal here, and this T1 and this normal 2 both are parallel here. He is saying T1 and normal 2, this is normal, always both are parallel to each other here. He is saying this point about this one here. And the next point, if you look at the next point in that right hand side, if the tangent and normal at any point, if the tangent and the normal at any point P of a parabola, at any point P of the parabola meet the axis at T and G respectively, meet the axis at T and G respectively, then ST is equal to SG is equal to SP here. So here, if this is a tangent point here, this is a normal point here, and P is a parabola, P of the at any point on a parabola P here, this is tangent, this is normal here respectively, then ST is nothing but focus, the distance between focus and tangent, and distance between focus and normal, and distance between focus and point are always equal. About this point he is saying. And the next point is, if the normal at any point T on a parabola, this is the parametric form. If a normal at any point on a parabola T, y square is equal to 4ax is a standard form of parabola, subtends at a right angle. See, if a normal, this you write a diagram, this is a point here T, and this is the focus, this will be the focus, and this will be the vertex. Here right eye subtends the right angle, this is right angle, this is right angle, here this is also right angle, and this is also right. If you go for focus, it is also right angle triangle, it subtends a right angle triangle, and for vertex is also it subtends a right angle triangle at normal point T here, at normal point, the point of intersection of normal and tangent is called point of contact and a parabola here. And next point, the length of the normal chord drawn at any point T on a parabola, the length of normal chord, the length of normal chord drawn at point on the parabola of standard form of parabola, y square is equal to 4ax. You have to remember this formula, 4a of 1 plus t square whole to the power of 3 by 2 and divided by t square. This is the remembering formula. Remembering formula for length of normal chord. This is the first expression to find the length of normal. This is the first expression to find the length of the normal drawn at any point T on a parabola, that is equal to y square is equal to 4ax is 4a of 1 plus t square whole to the power of 3 by 2 by t square here. And the point of intersection of normal drawn at T1 and T2, the point of intersection is nothing but they are intersecting at one point, that point is called point of intersection, that is, those are tangent normal here, T1 and T2 to a y square is equal to 4ax is parabola equation. Then this is the most important formula to remember to find the point of intersection, where 2a plus of a of t1 plus t2 whole square minus t1 t2 comma minus of a t1 t2 bracket t1 plus t2. This is the most remembering formula for to find the point of intersection of a normal and tangent here. This is the most important one. In next, if the normal at t1 on y square is equal to 4ax meet it again at t2, then the T2 square, T2 is equal to minus T1 minus 2 by T1. Here a normal at T1 on y square is equal to 4ax parabola here meets again at T2, then the condition for this is T2 is equal to minus of T1 minus 2a T1. This is the expression to find the normal. At 2 points are meeting each other. And the next one, if the normal at the point T1 and T2 on a parabola, that is y square is equal to 4ax, meet again on the same parabola at third position. If the two normals are at T1 and T2, again meets the third position. Then two conditions are there. T1 into T2 is equal to, this is the one condition, and the sum of 3 T's is equal to 0 here. This is the next point for this one. And here this is the point. If T1, T2, T3 are the feet of the normals drawn from a point P of x1, y1, these are the 3 feet of the normal. 3 feet of the normal at point P of x1, y1 to the parabola. Y square is equal to 4x is a standard form of parabola. Then the roots, this is the condition for feet of the perpendicular to a normal. 3 feet of the perpendicular, at cube plus minus of 2a x1 into t minus y1 is equal to 0. And hence these are 3 conditions: T1, T1 plus T2 plus T3 is equal to 0, and T1, T2, T3, T3, T1 is equal to 2a minus x1 by a here, and the final one T1, T2, T3, the product of 3 t values y1 by a here, and here sum of 3 values is 0 here. This is the important one for feet of the perpendicular here. And the next one, at most 3 normals can be drawn from a given point. 3 normals can be drawn at given point to a parabola. At most, here he is saying a theoretical information. At most highest, we can draw 3 normals at one point of a parabola here. This is the important one here. And the next one, the sum of the ordinates of the feet of the normal drawn from a point to the parabola y square is equal to 4ax is 0. This is also informative point here. The sum of the ordinates is nothing but, for example, x ordinate, y and x comma y. The sum of 2 ordinates, feet of the normal, feet of the normal x comma y, there the sum is normal to the from the point to the parabola y square is equal to 0. Here if you get any point here, that is 3 comma minus 3. The sum of these two values becomes 0 here. 3 minus 3, that will become 0, and minus 3, 3. Here these two numbers are equal in a point, and one is positive, one is negative. Then only it will be negative. The sum of 2 ordinates here. This is the theoretical information about this one. And the final point for this one here, the centroid of the triangle formed by the centroid. Centroid is nothing but centroid. This is the triangle I am taking. Centroid is nothing but diagonals, midpoints. This is the centroid here. See here, the centroid of the triangle formed by 3 normals of a parabola. 3 normals of the parabola like this. After drawing 3 normals of a parabola lies on its axis. The centroid, for example, if you take a parabola, for those normals, this is a tangent here. For those normals, this is a triangle. This is a triangle formed here. This is a triangle from normals triangle. From this triangle, the centroid will be lies on axis. That is the point he is saying. See here. So if you take 3 points, this is the parabola. These are the 3 normals. This is the one normal, and this is also one normal, and this is also one normal. These 3 normals. From these 3 normals, here it framed a triangle. For those triangle, the centroid will lies on this axis only. This is the theoretical information about this one here. And next one is reflection property of a parabola. The important one is reflection property of a parabola. This is a small concept. Reflection property of a parabola. Reflection property of a parabola here. And if you look at this concept here, so first of all I am taking a coordinate axis here. This is axis, this is axis, and if you take a parabola, this is a parabola I am taking, this is parabola, and a ray is incidenting on parabola, a ray is incidenting, this is a incidenting ray, incident ray, and it is reflected back. It is reflected back. This is the focus and it is reflected back. This is a reflected ray. This is a reflected ray and an incident ray. Here the concept is an incident ray is incident on parabola. This is the parabola and reflected back and passing through focus. Passing through focus is called reflection property of a parabola. Every incident ray is incident on parabola, that is reflected back and passing through focus. That is the reflection property of a parabola. This is all about the normal of a parabola concept here. And in this session we discussed all the information about parabola here. In next session we will discuss the problems related to parabola and modules. Thank you.